My name's Chris and I repair my own audio equipment, and I also show you how to repair yours. So let's get started. I'll show you the simple step-by-step approach that I use to fix my vintage audio equipment. You can repair your vintage electronics. For my successes and for my failures, I'm going to show you how in this video. I'm going to start with my top screw-up. The number one mistake I made when I first started repairing vintage audio equipment was that I didn't test it well enough. I didn't go through and test the equipment well enough. So I thought I knew what was wrong with it. I took the cover off it. I started working on it. The problems I had, I didn't know if I caused them or if they were there to begin with. So the first step, and once you learn this, you're going to save yourself a lot of time and headache, is whatever piece of equipment it is. Doesn't matter if it's a tuner, an integrated amp, it's a separate, it's a receiver, it's a tape deck, whatever it is and whatever it does, test it out thoroughly before you ever take the cover off. Don't take the cover off. Test it, test it, test it. If you follow that advice, that's going to save half the headaches you'll ever run into repairing vintage audio equipment. You may be thinking, well, common sense tells you to test it, Chris. But a lot of times, what happens? We get in a hurry, we've got a problem, we want to look at it, we want to fix it, and we miss something else. Now the question becomes, can you reproduce the problem 100% of the time? Or is it something that comes and goes, or is very intermittent? That's something that's very important to find out before you start troubleshooting, so you go in the right direction and you're not chasing your tail down the road. Before you remove that cover for the first time, you need to be 100% sure you know what works and what doesn't work within the piece of equipment. And if you do, you'll be well on your way to fixing your problem. And the reason you'll be well on your way is because now you're able to narrow down where your problem is. Because in the 1960s, 70s, and into the early 80s, audio equipment was designed in sections and manufactured in sections or individual assemblies. So if you can narrow down where your issue is, it's much easier to fix the problem because many times you can narrow it down to one section or module or maybe two. Another mistake, or maybe more something like I didn't realize it, is that the documentation for almost all vintage audio equipment was available online, which is a must-have if you're going to repair or restore your vintage audio equipment. Let me show you in a short explanation how helpful this information is. Here's the block diagram for a Pioneer SX1250, which was a receiver that was manufactured in the late 1970s. And as you can see, it's laid out in various sections. Tuner section, EQ amplifier, which by the way is the Phono section. It has the control section, which is the preamp, and has the power supply, has the power amplifier, and has the protection circuitry. Each of these sections are on separate assemblies. So when you narrow down that problem that you're having with a piece of equipment, it makes it much easier to solve the issue because you've eliminated most of the circuitry within a piece of equipment, except for the circuitry that is probably causing your issue. So the previous image showed you a block diagram of the SX1250. Here's an image of it looking down from the top, and let's assume you've got a FM issue. Well, there's the tuner assembly and where it's located within the SX1250. And you can see if you can narrow down an issue, you eliminate a large portion of the piece of equipment that you're working on. And by doing that, that's going to make it much easier to fix your problem. All the illustrations I'm showing you, I got out of the Pioneer SX1250 service manual, which I downloaded from HiFiEngine.com. Now, it's my understanding that a lot of people are having issues downloading from the site. I fortunately have not had any issues, and I just logged in a couple days ago and I had no issues downloading a couple things. It seems like the main issue is anybody new trying to sign up, they're just not taking any new accounts. And I've also seen some people posting about they can't get in anymore. They can't log in, or they can't download, or there's just some issue. So any of you guys that have any other sources for manuals, please post them down below, because it's going to help people today and in the future to be able to find the service manuals to repair this vintage audio equipment. So I've been talking about a Pioneer SX1250 and the way that it was designed and manufactured, but it doesn't matter the manufacturer, it doesn't matter the model that you have. They all were designed and built in similar manners, and no matter if you've got a Marantz or a Sansui, whatever it is, the process will be the same. And all of these manufacturers use the technology of the time, so there are more similarities between manufacturers and models than there are differences. So if you've got a piece of solid-state audio equipment that was manufactured from the middle 60s up through the early 80s, this guide will really help you out of how to go about testing and repairing that piece of equipment. So even though I'm showing a Pioneer SX1250, when you download the service manual for your piece of 60s to 80s equipment, it'll look very similar and you'll feel right at home when you see it. Alright, now it's time to move on to get your piece of vintage audio equipment working. We need a few hand tools. We need some screwdrivers, we need some pliers, we need some cutters, we need some Allen wrenches, and you may need a small socket set. And that's about all you'll ever need to fix vintage audio equipment. Alright, that covers the hand tools, and most of you guys probably have what you already need. Now, one more thing that you really got to have to fix vintage audio equipment is a digital multimeter. You don't need a high-end one. Get on Amazon if you don't have one, and buy a $15 one. It'll work fine for you. And if you do find out you get into electronics and need like a little bit better multimeter, you'll always find a use for that cheap one. So those few hand tools and an inexpensive multimeter, and you can expect to fix many different issues that come up with vintage audio equipment. A very common area of failure is the power supply. Power supplies are under a lot of stress in old electronics, and certainly they're under stress in vintage audio equipment. And many times the failures are in the power supply, and you've got a meter, and so now you can measure voltage and see what that voltage is. You're also able to measure components that have gotten old after decades. You can measure if a resistor has opened up or if a capacitor has shorted out. So there's a lot of troubleshooting you can do with just a few hand tools and an inexpensive multimeter. I'm going to go over some specifics about how to troubleshoot your issue with your vintage audio equipment, but first I want to tell you a little bit more about the service manuals that were produced for this equipment and why they were produced. All of the illustrations and schematics that you're seeing are in the service manual. The point I want to make is the service manuals contain a lot of information because this was way pre the internet. So the corporations like Pioneer who made this SX1250 gave the service centers, gave the shops that were selling their equipment as much documentation as they could because they didn't want to get barraged with phone calls to California or New York. They've got a problem, they don't know what to do. So the service manuals are usually pretty informative, and they even in this SX1250's case, they give you a bunch of circuit descriptions because they're trying to get the technician, whoever that may be, there were thousands of them back in the day, and all different levels of skill. They gave you a ton of documentation so that you could take care of yourself when you had an issue. There's a lot of documentation on the old audio equipment. Always do a Google search for your piece of equipment, and most of the time you can find out a lot about it. And by finding out more about your piece of equipment, that's going to allow you to fix it easier. Just makes sense. And in my case, I find this stuff interesting. How much of this do I understand? To be honest, not a whole lot of it. But you read it over and you read it over again, and then you look at another circuit and then another circuit, and over time it starts making a little bit more sense to you. And as I said, in this era of equipment, this Pioneer works in a very similar manner to any other manufacturer of the time. So I just wanted to share that information with you because the service manual has some critical items like that schematic that you've got to have, but also many of them have information like this SX1250 does that's both informative but also interesting, and it gives you a better feel for the piece of equipment that you're working on. Alright, now it's time to get back to where I was. How to maneuver through your schematic so you can fix one of the most common problems in vintage audio, which is power supply issues. The reason why there are so many power supply issues in vintage audio equipment is the same as any other piece of electronics. What kills components is time, and as you guys know, vintage audio equipment, we've got that one covered, and heat. And so when you combine heat and time, you've got a better chance of components failing. Now I'm going through the service manual on a Pioneer SX1250, as I've said several times, but I just want to make it clear that you probably don't have an SX1250, and it doesn't matter because the service manuals are very similar for all the manufacturers and all the models. As you'll find at the top of the service manuals, the contents has all kinds of information, circuit descriptions, and the block diagram we looked at and other stuff. But down here, just not too far in, it shows all the different assemblies in this 1250. We're going to go down here and find the power supply. And this is, again, why I picked this particular assembly, is this is another one. Now you've got power supply assembly, that makes sense, that's what we're looking for. But really the majority of the voltages in this unit is supplied by what they call the stabilizer assembly. So I want to just show you again and make it clear that sometimes the wording could confuse you if you don't look at it a little bit closer. So you scroll down here and it was page 93, 95. There's the stabilizer assembly, the AWR 106 right here. And now you can see from that block diagram we were looking at earlier that just kind of said, well, we've got a power supply in the unit. Now we've got a lot more information here. So now you can see a lot more detail about what the power supply entails. And the great thing about this now, a lot more information. It shows you the pin numbers on the power supply, and even better yet, what you should see on those pins. 65 volts on pin 11, 25 on 10, 12's a ground. So if you've got something wrong, let's say with pin 13, which says 65 volts, you can follow this back and look at other voltages at different spots and help you narrow down where your problem is. You know, you've got the resistors, the capacitors, the transistors, the diodes, everything has a designation that corresponds to the schematic. And this is how you're going to end up being able to fix your problem, because you're going to take a look and you're going to find an issue, and then you're going to find that component on that assembly, and you're going to change it out and you're going to get your equipment going. So the next illustration is actually showing you the positioning of all of those components on the actual assembly. So if you take a look at this assembly and then take a look at a physical stabilizer assembly, you can orientate it in a way to know where, for example, R3 is, or Q2, or whatever it happens to be. This will allow you to be able to find the components, measure them, and troubleshoot from there. And again, here it's showing you voltages at different points. The idea is for you to trace back an issue. And without this information, the average technician probably wouldn't be able to fix it, because you don't know if you're supposed to have 25 volts there or 45 or 36 volts or 15. Most people don't. You can see this service manual was marked up. You know, I downloaded it off the internet, and you can see somebody had already penciled in different, what I would assume are voltages on the different pins. And keep these pins in mind, because they correspond to the pins of the illustration you just saw up above. And then these pins coming out of the power supply go to other assemblies. Hope you can see how you're able to narrow down an issue, and when you do narrow down an issue, it helps you so much in trying to find what the problem is. So you can get it fixed and get back to enjoying your vintage piece of stereo equipment. You may be thinking, well, where is the stabilizer assembly and the power supply assembly located in a Pioneer SX1250? Again, it's in the service manual, and it'll be in the service manual for whatever piece of equipment you're working on. In the 1250's case, the stabilizer assembly is located at the top and the power supply is located at the bottom of the unit. Okay, that's enough about talking in detail about the service manual, but it's so important whether you're a beginner or you're an expert and you've been working on vintage stereo equipment for years, you've got to have that service manual for your piece of equipment so that you can hone in to exactly where your problem is located at. Some hand tools along with an inexpensive digital multimeter will allow you to fix many different issues, but it won't allow you to fix every issue in vintage audio equipment. So now let's get a little bit deeper into troubleshooting vintage audio equipment and fixing them. And the good news is you don't need expensive digital oscilloscopes. You don't need expensive signal generators to fix vintage audio equipment. But with that being said, sometimes you do need a signal generator and sometimes you do need an oscilloscope. Where an oscilloscope is really a benefit is when you have an issue with one channel. You've got one channel that's bad in some way. Maybe you have distortion in the bad channel. Maybe the channel's out completely. Whichever the case, if you have one good channel, when you think about it, in a piece of stereo equipment, you have two channels. You've got a bad one, you've got a good one. You can use the good one to compare signals as you follow along on the schematic. You can compare and say, I don't know what I'm doing, but I do know I've got this signal at this point, and I don't have it at this point on the bad channel. So when you think about it, you really have an expert sitting right there with you, the good channel. Who knows this stuff better than the circuit that you're trying to fix? So when you find that difference between the two channels, you can take one step back and see what's causing the problem. You can't use music as the signal. If you do that, you won't be able to follow it along. It'll look more like the oscilloscope on a Marantz 2500, and you won't be able to make heads or tails out of it. So that's where the signal generator comes in. You can set it to any frequency between 20 hertz and 20,000 hertz, but usually using 1 kilohertz works really good in troubleshooting vintage audio equipment. Then you've got a good steady signal to do your troubleshooting with. For you guys that have a signal generator and an oscilloscope, you guys are all ready to go. You don't need nothing else, as long as you got that digital multimeter and a few hand tools. Now for you guys that don't have a signal generator or an oscilloscope, the signal generator is the easiest because you've got a signal generator right there with your phone. All the different models, it doesn't matter the manufacturer, they've all got signal generator apps that'll work fine. So you've just got to go find that app either at the Apple Store or wherever, depending on what kind of phone you've got. And it can be anywhere from free to $5 for a more professional signal generator app. You'll also need a cable to be able to get the tones out of your phone into the stereo equipment that you're trying to test. And they run anywhere from $5 to $15. You'll have to look on Amazon or wherever for your particular cable. In my case, I have an iPhone. It's a Lightning port to RCA cable. If you need an oscilloscope, almost anything would work in the last 50 years. So if you want to pick up an old used Tektronix like I've got, just make sure it's got 2 channels and make sure it's got 2 probes, you're ready to go. There's a whole bunch of real cheap digital ones out there. I know nothing about them. If they'll just look at a 1 kilohertz signal, you're good to go there. You're not looking for anything special. You can troubleshoot vintage audio equipment with almost any of them. So now I'm going to go over the different types of problems that you're going to run into when you troubleshoot your piece of equipment. But real quick, let's recap what's already been gone over. One is to test that piece of equipment every way you can to make sure you understand what's really wrong with it. Number 2, you need that service manual for whatever piece of equipment you're working on. 3, you need some basic tools along with a digital multimeter. And 4, if you're going to do advanced troubleshooting, a signal generator and an oscilloscope. All right, now you're ready to fix your piece of equipment. In step 1, you tested out every feature of that piece of equipment. You found out what it does, what it doesn't do. Now the question becomes, can you repeat that problem over and over? Every time you turn on the unit, for example, the left channel works, the right channel doesn't. You've tried every input, you get the same results, and you turn off the unit, you turn it back on, you get the same exact results. That's one possibility of having a failure. You can repeat it. The other possible failure mode is something that's intermittent. So we'll use the same example. You turn on the unit, the left channel works, the right channel doesn't. But then, all of a sudden, the right channel comes back. Then you turn it off, then you turn it back on, the left channel working again, and the right channel's kind of coming and going. You may be thinking, well, why is that important? It's broke. It doesn't sound right. It's either not working, it's intermittent, but there's a big difference in how you approach an intermittent problem to a problem that is repeatable over and over. For the issue that you can repeat over and over, you need the steps that we went through, 1, 2, 3, and 4. For a problem that keeps changing on you, you may not need steps 2, 3, or 4. You still need step 1 because you had to go through the unit to see what's working and what's not. The most common solution to intermittent issues in vintage audio equipment is cleaning dirty controls. Any of the knobs or buttons on the front of your unit are possible troublemakers. And really, if you've got one that is a possible troublemaker, they probably truly all are. What'll happen is if you think you narrowed it down to one particular switch and you just clean that one switch, most of the time you're going to get it back hooked up and you're going to have some kind of other intermittent problem. So if you do have that issue in your equipment, you've pretty much got to go in there and clean them all to make sure that you get rid of the issue and your unit operates properly for years. And the majority of intermittent issues are those controls. That's the good news. It's not just 1-2% of the time. No, it's probably 3/4 of the time. If you've got an intermittent issue with your vintage stereo equipment, there's a really good chance it's one of those. There's other issues too. There's component issues, noisy transistors, and different things. But if you've got an intermittent issue, a lot of times you can solve it with cleaning those controls. And let me tell you how to do that. First, let me tell you about the controls that you're going to clean and that you're going to run into in a piece of vintage audio equipment. I'll start with the push button switches, and these are switches, they're either on, they're off. As you can see from this SX1050, they're used for like the speaker select, the high and low filters, to select what input you want to listen to, FM, auxiliary, etc. And they are notorious for being flaky if they're dirty. You may push one, and you may lose one channel, you may lose them both, and push them again, and both channels will come back and it'll seem like it's working great. And in my experience, these push button switches in any brand, I'm showing you a Pioneer, but it can be any brand of vintage audio equipment, they've been the most flaky for me. The second switch type you're going to run into is a rotary switch, and those are used typically for your bass, your treble controls, something that has various positions. It's a multi-position switch, and from my experience, unlike the push button switches, you don't normally lose audio with these. You can, I'm not saying you can't, but typically what happens is this is where you get that scratchy sound when you use a control, or you hear a click or a pop. It's not a total loss of audio, but you hear something that you shouldn't be hearing. The third type of switch is a toggle switch, and for me, I've had issues with these similar to the push button switches. They're more inclined to just be flaky, make you lose a channel, or reduce volume in a channel. You can mess with them and get it back running, and then you move them again and you have an issue. But in the toggle switches defense, I haven't had nearly as many issues with them as I have with the push button switches. I'm going to get into cleaning those controls, but first, before I do that, you need to ask yourself, should you do it at all? Is it more trouble than it's worth? In one way, it's not that difficult to do. You take some spray, you spray it in the control, and you exercise the control 30, 40, 50 times. Doesn't sound hard, right? The difficult part, almost 100% of the time, is getting to the control. Take a look at any piece of equipment you've got. Are you going to be able to get to that control? Are you going to be able to take some sort of spray and spray it anywhere? No. You're going to have to take every knob off the unit. You're going to have to take the faceplate off the unit. Then many times you're going to have to remove those assemblies so you can get at the controls. So if it were me and I had a piece of equipment that just was a minor annoyance, that I knew sometimes I was going to have to push the high and the low filter a few times, or I was going to have to move the balance control a few times, or whatever it is, then I wouldn't do it. Because you can't do it without this being somewhat of a big project. Because every time you open up these units and you start unhooking these assemblies, you can bust a wire, you can get into various other issues that you wouldn't have had if you just left it alone. If I had a unit that wasn't a big deal, it wasn't causing me a big problem, I'd just leave it as is. Now, if you've got one, you just can't enjoy it. Every time you turn it on, you can barely get the left channel to work, and sometimes it does, sometimes it doesn't, and you gotta clean them, then you gotta clean them. Another reason you may want to clean the controls, you want your piece of equipment to work like it used to work. And that's a valid reason too. You want it to work like when it was new. And most likely it would work like it was new if the controls were cleaned. It's really a personal decision. How bad's your issue? And also, how much do you want this unit to work like when it was new? I use DeoxIT products, but there's other ones out there that'll work just as well. Just don't clean your equipment with contact cleaner or something like that. Really, all you need is DeoxIT D5. I've got a bunch of different ones. You don't need them. DeoxIT D5, one a can of that, costs you $15, $20, and you'll be set to go. First up, cleaning those push button switches. On most pieces of equipment, you can remove the faceplate and get to the push button switches. The only issue you have is you probably will not be able to see where the spray is actually going, and that could be an issue if you're not getting it up in the switch correctly. Where you spray is up toward the front of the switch near the spring, and if you take a look at the switch itself, if you get the spray in there correctly, you can see a small little point in the center of the switch, and the DeoxIT spray will come right out of those switches if you get it in there correctly. You have to exercise each of these switches 30, 40, 50 times. I know it always sounds ridiculous, but the first time you take one of these apart and you've still got an intermittent issue, you'll wish you'd done it 30 or 40 or 50 times when you're ripping it back apart again. Some folks will also disassemble these switches to clean them. I wouldn't recommend you doing that. I've never had an issue being able to get them cleaned up the way I do it, and it's just one more chance to get in trouble and to damage your piece of equipment. DeoxIT's a really great product, but it's also very messy. So when you use it, be careful where you're spraying it, and you're better off if you can put like some kind of little protection around whatever you're spraying. That way if you overspray, no big deal. And if you do overspray, no big deal either. Just wipe it up with a rag. The rotary switches are just like the push button switches. If you can get the DeoxIT spray in there and you exercise that control 20, 30, 40, 50 times, 99% of the time that's going to get rid of your intermittent issues. But the challenge, just like the push button switch, is getting the spray into the control and not all over the place. And you can see in this picture, there's a hole, and that's where the spray has to go in. Many times these controls are basically sealed except for a small opening. This holds true for most balance and volume controls in vintage audio equipment. Now you can see in this picture, it'd be nice if it was sitting on the table, but yours is sitting in your receiver. So it's going to be much more difficult to clean your control than it would be to clean this one. Here's the assembly that contains the bass and the treble controls in a Pioneer SX1250. Are you going to be able to get to that? No, you're not going to be able to get to it if it's in the chassis. The only way to really clean those controls is to remove it from the chassis, and as you can see, with it in my hand, it's quite easy to clean. But in the chassis, it's impossible, as this assembly sits at the bottom of the chassis, with other assemblies sitting above it. Then there's the toggle switches. This assembly is from a Pioneer SX1250. It's got 6 toggle switches on it. It's got the balance control. It's got the volume control. Anyway, I think you guys get the gist. If you can get to them, you can clean them pretty easy. It's getting to them that's the difficult part. So there's going to be some disassembly in most pieces of vintage audio equipment to be able to clean these controls properly. And that's why I said, if your problem's not bad, I'd leave it alone. I don't know about you guys, but I rarely mess with any of the controls on my pieces of equipment. Of course, I use the volume control. Of course, I use the input selectors, but besides that, I don't push the buttons very often, and a lot of times you get your piece of equipment happy, and if you don't mess with the low filter, the high filter, the tone controls, etc., it'll work fine. As I said before, you've just got to decide for yourself whether it's worth cleaning those controls or not. So now let's look at those issues that you can have that aren't intermittent, that many times are caused by the controls. But every time you power up your unit, the left channel doesn't work. Or maybe the unit doesn't power up at all. Or maybe it looks like it powers up, but there's no sound. So how should you approach these type of issues? Earlier I touched on how you can use a signal generator and an oscilloscope to repair an issue if you have a problem with just one channel. So let me go ahead and show you how I repaired a Sansui AU9900 integrated amplifier that had an issue with the left channel only in the phono position only. The rest of the amplifier worked fine. It was just when you used the turntable in the left channel, that was the only thing not working. And keep in mind, it doesn't matter what brand, what model piece of equipment you have, or what your issue is. Maybe your FM's not working. Maybe none of your inputs work in one channel. You would use the same technique I'm going to show you now to fix your piece of equipment when you have a problem where one channel is working and one channel isn't. So now I'm going to show you how I troubleshot the issue I had with this AU9900 where I had no left channel from the phono input using these same tools I just showed you. The left channel was totally dead, absolutely no audio. The right channel sounded great. I know I mentioned this before, and you probably get sick of hearing it. You must have the service manual for your piece of equipment before you take the cover off, before you try to attempt to fix it. So I've got my service manual, and I'll go to the table of contents and look for that F2570 equalizer amplifier board. Now I'll go to the page that has the F2570 equalizer board schematic diagram. If you've got one channel operating properly, you've got a big advantage when it comes to repairing the broken channel in a piece of vintage audio equipment. And again, it doesn't matter if it's this piece of equipment or a different piece of equipment. I talk about experience working on this equipment, but who's got more experience than that other channel? Nobody knows this equipment as well as that other channel does. So that's a big advantage. You can take a look on the good channel and see what you've got, whether it's a voltage, whether it's a signal, whatever it happens to be. You're able to check the good channel and compare it to the bad one. So that's a big help when you're looking for a problem and you may not be very experienced. Or if you are experienced, it's a big help. But before I get carried away tracing out signals, the first thing you always want to do when you've got an issue is check the voltage. All you need is that digital multimeter and make sure you've got voltage to the board. In this board's case, almost certainly the voltage is okay because the right channel's working properly. The voltage that comes from the regulated power supply for this card is used by both the left and the right channel. They're not separate voltages that are coming from the power supply. So most likely that's okay, but you want to check it just to be sure. With the voltages being fine, now it's time to move on to some more troubleshooting techniques to try to figure out what's going on. And this is where having a signal generator and an oscilloscope is so helpful. Could you fix this problem with just your multimeter? It's going to be difficult because at this point it's so much easier to feed a signal into the phono inputs and take a look at it at the outputs. It's not totally hopeless if you just have a multimeter, because you can go in there and see if you've got a bad transistor. You can still measure resistance between the base, emitter, and collectors on these transistors and get an idea if the transistors are bad. You can look for a shorted capacitor. So it's not totally hopeless. It's just easier with a signal generator and an oscilloscope to find an issue with one of the two channels. Now I'm going to hook up my signal generator to the Phono RCA inputs on the side of the AU9900 and follow the signal through the phono section and see where my issue is. I can also compare, as I mentioned earlier, the good channel at different points to see where the signal's good and where I'm losing it. So on the schematic, to the left are the RCA inputs, over to the right's the output. And you can either use Phono 1 or Phono 2, it really doesn't matter, because out of pin 3 we should see the amplified signal through this card. I keep talking about pin numbers, but I think I ought to show you where those are on the card and on the connectors that come into this card. There's 4 different pins that we're concerned with: pin 1, pin 2, pin 3, and pin 8. So pin 1 is the positive 32 volts from the power supply. Pin 2 is the negative 33 volts from the power supply. Pin 3 is the phono output, and pin 8 is the phono input. Now we know pin 1 was good. We know we have our voltages on both pin 1 and pin 2. So the two important ones are really pin 3, which is the phono out, and pin 8, which is the phono in. Pin 3, the phono output, goes directly to the preamp after this card has amplified that low-level signal from your cartridge. And pin 8 is the input that comes directly from your RCA jacks, and that is a very low level signal that's created by your cartridge in your turntable. Keep in mind, in these graphics I'm just showing you one channel, the left channel, the one I'm having a problem with. The right channel, we'll be using him too to compare signals, and his input comes in pin 11 from the RCA jacks, and his output goes out pin 6 to the preamp. So how low is low? Most modern moving magnet cartridges put out 3 or 4, maybe 5 millivolts, so it's pretty darn low, much lower than the preamp can use to get your volume up to any usable level anyway. So that's why we have in this unit this F2510 equalizer amplifier, and every unit, doesn't have to be this one as I mentioned before, it can be any vintage unit that has a phono stage in it, operates similar to this. One thing I've learned over the years, the less you have to put your hands in a unit, the better. Better for you, and more so, better for the equipment. So you may notice the scope probes are hanging down the front of the AU9900. And the reason they're doing that is I've taken a piece of 20 gauge wire, left the insulation on, stripped both ends, and then I've pushed that wire down into the connectors so I can look at the signals. And I've taken that wire just long enough to hang over the front, hook the probes to it, so I don't have to worry about a probe coming loose inside the unit somehow. Maybe I bump it, maybe it just comes loose. It happens, shorting something out and causing more issues. Now you can compare your good channel with your bad channel. As I mentioned, the best thing to do, get a signal generator, input a 1000 hertz sine wave, and just take a look at it through whatever circuit you're trying to troubleshoot. If you've got one channel that's got an issue, normally it'll be readily apparent there's something wrong. Like the image on the scope here, channel 1 was hooked to the left channel, channel 2's hooked to the right channel. Well, the right channel looks like a normal sine wave. The left channel, not so much. And as I said before, I'm troubleshooting an issue with the phono section of this amplifier. But this works for a preamplifier, an amplifier, a receiver, any piece of equipment where you have one channel working and the other one not. At some point, you have to get down onto this card to troubleshoot the issue you have. It was nice that we had connectors here, that we could see the signals coming in and going out, and we determined that there's something wrong with the left channel. You have the sine wave coming in, and the sine wave going out looks not correct. So, but where is the problem? And that's where you use the schematic to find different points to check the signal. And remember, if you're looking at something, you're not sure if that's right, you can look down here on the good channel. These are identical channels, so you've always got the good channel to compare a signal to. The issue in here is when you're in here with a scope probe, a meter probe, you can short things out easily. And you've got to be very careful. And that's why you really should use some sort of test clips in here. And what works very well, I don't know if you can see this or not, I'll try to set it here. It's these little mini grabbers. They're used a lot in electronics. I don't know if you can see the little pins moving. And you can just go ahead, put the wire in, bring the wire outside the chassis, and it's all insulated. You have no worries. Now, that's a lot safer than going down in here with a scope probe, a meter, whatever it is you're using for test equipment. If you're comparing the two channels with each other and you find that there's a difference in the signal, you've got to be able to repair it. You've got to be able to say, okay, I see a difference. Now what do I do? This board sitting down in here, I've taken my test leads, I have them hooked up, I see a difference. Now what you have to do is to be able to first of all look around the area and see if you see anything that looks obvious. I've seen components that were burnt, transistors with legs blown off. It kind of gives you an idea if something bad happened. But now the idea is to figure out what's wrong. And with that, you have to get this board loose. You have to remove it. So with the board loose, if you want to continue doing some troubleshooting, you've got to be able to get those connectors back on. And sometimes there's not a lot of slack when you're holding it up like this, and I'm having a little trouble getting the one on because I don't have a whole lot of cable to do it with. I am able to get it back on there, but sometimes you got to find a tie wrap somewhere else in the unit. Somewhere you can usually get that extra inch or two if you need it. But now you've got it hooked up, and it will work just like if it were screwed down into the frame. The issue is you've got to be very careful now. It is loose. You've got to make sure that that board does not short up against the frame, because that entire frame is metal, it's ground, and most likely something really bad's going to happen if that artwork side of the board touches that frame. But now I can pull it up, I can get down under there and take my scope probe or take my meter and do more troubleshooting, and certainly I can see the under part of the board to make sure there's not some issues with the artwork, and there are sometimes. You'll find cracked artwork or questionable solder joints. So I'm able to take a look under there and still have it powered up. But as I indicated, you've got to be extremely careful when you have it powered up and you have an assembly loose like this, because it's easily shorted out. I've found that a piece of cardboard works well in most situations because it's flexible enough to bend around a little bit to get where you need it, but it's also steady enough that it doesn't collapse like a piece of paper would or some other material. Now sometimes I'll use a piece of paper just to protect from scratching something. These assemblies have a lot of sharp points on them, and it's easy to scrape your paint on the inside of your chassis, and why do that if you don't have to? So I'll put a piece of paper under an assembly sometime just for that reason. After troubleshooting, you think you may have a bad transistor. How do you go about testing that with your multimeter? Up here on YouTube, I found a great video about how to test silicon transistors by Marcus Fuller. And in under 3 minutes, he explains how you can test a transistor and tell if it's a PNP or NPN. And I did have a bad transistor, a 2SA798, which is a dual package transistor. Those are no longer available, but it's a pretty easy fix to make your own, using 2 KSA992 transistors, which are just pennies a piece. I don't want to get too involved in how to replace obsolete transistors with modern transistors, because it's beyond the scope of what I'm trying to show you guys who own a variety of different pieces of equipment from the middle 60s through the early 80s, and going into detail about one particular issue is not going to help you guys get started with repairing your piece of equipment. But showing you the process I went through to get to this point is, I think, very important, and hopefully that showed you guys that you can take your piece of equipment and have a shot at fixing it yourself. I just showed you the process for troubleshooting an issue if you've got a problem with one channel. But what if you've got an issue with both channels? What do you do? There's two different scenarios here that I've seen when a unit's got an issue with no audio. And I'll go over the first one for me, which has been the most common one, is you power it up. It looks like it powered up. You've got dial lamps, maybe even your FM tuning works, but you have no output from either channel. You don't have any hiss. You don't have any, you don't have nothing. Normally, in that case, it's because the speaker relay did not engage. There's something wrong that stopped that unit from connecting the amplifier to your speakers. Now, if you've got a Marantz product and you happen to hear that speaker relay go and you don't have any audio, make sure you don't have one of the units that need a jumper between the pre-out and the main in, and those are located at the back of the unit. I've got two Marantz receivers, a 2245 and a 2270, that if you pull those jumpers out, no audio. The speaker relay will go, but you'll have absolutely no audio whatsoever. Now, not every Marantz is like that. I've got a 2285 receiver, and I've also got a couple 2500s, and they don't use the jumper. So you've just got to do a little bit of research on your piece of equipment and make sure that your issue with no audio isn't a very simple one. Well, for most of you, I'm sure it was more than the jumper causing you a problem. So just like when you have an issue with one channel or the other, when you have no audio, go and the speaker relay doesn't go, we narrow down the problem. That's the whole key. Narrow down the problem, where when you look inside your piece of equipment, you're not going, where do I start? You'll already know where to start. So what inside an amplifier or a receiver will stop that speaker relay from engaging? Let's take a look at my Marantz 2245 and find out. Look how gorgeous this schematic is that Audio Karma member made in 2018 for the model 2245 Marantz. Somebody took the time to do this and then to upload it so somebody like me could have it. There's a vast difference between different scans that you'll find up on the internet. Some are really good, some are really poor. I mean, I appreciate even the poor ones because somebody had to make the effort to scan it and upload it, but some you can barely read, so a schematic like this is really nice to have. When the speaker relay won't engage, you normally have 3 assemblies that are suspect. The 2 power amp assemblies or the protection circuit itself. And you can never totally eliminate the power supply, but in my experience, this issue is almost always in those power amp assemblies or the protection circuitry. So I already went over that you've got to get the service manual, you've got to get the schematic, and how similar that these units are that were built in the same era. On the left is a table of contents from the service manual of the Marantz 2245. On the right's the Pioneer SX1250, and you can see from the table of contents they're very similar to each other. A few names are different, but basically they were engineered the same, they were manufactured the same, using the technology of the day. So again, just the point I'm trying to make, it doesn't matter the manufacturer, it doesn't matter the model, it doesn't matter if it's a low-end or high-end piece of equipment. They were built very similarly from the middle 60s to the early 80s. And when I say low-end, high-end, I don't mean that the lesser priced, the lesser powered units were junk. They were engineered and manufactured with the same quality that the more expensive, higher powered units were. And that's why the inexpensive units are still survivors, just like the expensive units are. They're still here 50, 60 years later. When the speaker relay won't engage in a piece of equipment, many times it's because you have excess DC voltage at your speaker outputs coming out of the power amplifier. Either your left channel or your right channel has excess DC voltage, and the protection circuitry sees this, and it won't tie your power amp to your speakers through the speaker relay to try to prevent damage to your speakers. So what is excess DC voltage? How much? Most of these protection circuits operate between 500 millivolts and a volt. So if you've got less DC voltage than your protection circuit will allow, then the speaker relay engages and you've got music. Now, if you've got 500 millivolts or more of DC offset on your speaker outputs, you're probably going to have some audible issues, and it's not going to sound as good as it can, but it won't destroy your speakers. You always want to shoot for 0 millivolts of DC offset, but realistically, you're not going to be at 0. Anything down 10 or 20 millivolts is really excellent. Really, anything below 50 millivolts, you're not going to have any worries about some sort of an audible issue, and you can probably even go a little higher than that. And certainly anything over 100 millivolts is something to be looked into further. Before I continue on with the Marantz 2245 and showing you about how I troubleshot the DC offset problem with it, here's an issue with DC offset I had with a Pioneer SA9900 that definitely needed to be looked into further. This may have been the type of DC offset issue that this Marantz 2245 had before it finally failed permanently. Let me show you what I mean. I thought showing you this on a graph was the best way to go. This graph has a horizontal and it has a vertical category. The vertical is the DC volts and the horizontal is the timeline. And so this was captured in real time, and once this starts running, you're going to see this moving over a period of time. You're going to see the voltage going up and down. And this was measured at the speaker outputs of this SA9900. I just powered up the 9900 and it hasn't come out of protection yet, so we're just kind of reading random garbage here at the speaker outputs. Now, right there, it powered up. And let me stop it here for a minute. And you can see that we had a spike up to just under 80 millivolts. And that's normal. That's not an abnormal thing to see, because you can see right immediately it started to fall back down. So there's nothing wrong with that there. So let's keep moving on here. And it's just going along, and it's fallen down to about, oh, I don't know, 13 millivolts, 15 millivolts of DC at the outputs. That's good. And now look, though. Look at that spike. Let's stop it again for a minute. That spike down of about negative 85 millivolts is not normal. And this is the kind of problem, I say, that people don't even know that they have. And these are the type of things that maybe started occurring 5 years ago, 10, 20 years ago. And eventually their piece of equipment doesn't work anymore, and now they think it's broke, where they didn't realize it had been broke for years. And you kind of think, well, why didn't the protection circuit kick in here? What's going on? The protection circuit in this unit doesn't kick on until about 750 millivolts, about 3/4 of a volt. So as far as the amp's concerned, he's perfectly happy. Now, of course, your music's not going to be sounding as clear and as crisp as it can, and you're suddenly going to be listening to it, and you're going to say, well, boy, this amp doesn't sound all that good to me. Or you've been listening to it like this for so long, you think it sounds great. So let's keep going here. And again, it pops back about normal. There we have another little spike up. And it's just going along here, going along here. And this is something that is random. I could do this again, and you're going to get a different result. You don't get the same result every time. And take a look again. Now look at the spikes. Holy smokes, now we got some more coming. And this time went to, what, 130, 133 millivolts on the positive side, and down around in minus 50 or so on the negative side. That affects the way this amp sounds. You may not know it, though. You don't know it. And there's another spike. A big one down 152 and, I don't know, up 100 or so. But those are the type of things that affect the sound quality. You don't know anything's wrong. The amp's just sitting there playing along. But it does affect the way it sounds. All these DC voltage glitches happened in a minute and a half, not an hour and a half, not a day and a half. When you've got DC voltage riding on your speaker outputs like this, it's not a good thing. Even though, possibly, this amplifier will do this for the next 50 years, and you'll never have any issues with it other than poor sound quality. But there's a good chance at some point the amp's going to end up going into protection mode because the failure is going to be bad enough. And you just got to hope when that happens, it doesn't take out your vintage speakers along with it. What you just saw was another normal power up. Spiked up to about 80 millivolts, and then it just fell back down here to 10, 15 millivolts. And it's just going along perfectly happy. I'm going to go ahead a little bit in this one. The last one, everything happened right up early. But this one, as you can see, everything looks fine. It looks perfect. We haven't gotten any extra spikes. And I'll let it run here a minute and just show you what happens. Boy, that looks good. If you've got an amplifier doing what this one's doing, you'd say it is working great. Because it is. If it would just sit there at that 10 millivolt level, everything's wonderful. But I'm going to go ahead and jump ahead a little bit here. And I don't have to jump ahead too far. I've only got to jump ahead to around the 4-minute mark or a little bit better to show you what can happen. So I've jumped ahead here to about the 4-minute mark, a little bit over. And you can see, first 4 minutes of this being powered up, everything's whoops, what was that? We got our first spike, right? Over 160 millivolts, both positive and negative. That's bad, right? Now, almost 600 and almost minus 900 millivolts. Now that's going to put this amplifier into protection. That relay is going to click, and it's going to disconnect your speakers because that's too much. Now you're over 3 volts positive. 3 volts, not millivolts, and minus 2 volts. This is bad news. You don't want to have your speakers hooked up now, even though the amplifier is going to do its best to protect your speakers. This is not something you want to have happening. Now what will happen as that DC offset comes down under that 3/4 of a volt, after 4 seconds or so, this amplifier is going to reconnect itself to your speakers. And guess what? We're going to go through the same thing again. Let's try another 2 or 3 volts. Let's just see what happens. And then it's going to disconnect. And then it's going to sit there that 4 seconds, about 4 seconds or so. It times out. And then it's going to connect back to your speakers again. Do you want this happening? Nobody with any sense does, or nobody that's got any pair of speakers they care at all about does, because this type of voltage will damage your speakers. There's no doubt about it. The DC voltage basically turns your speaker into a heater, and the voice coil overheats, and end of story. When you have 36 volts DC like this 2245 has. Fortunately, the protection circuit's working in this unit, so it saved the day. All right, let's get back to the Marantz 2245. Now, with the issue I'm talking about where the speaker relay will not engage, unfortunately, we can't use a multimeter and just go back there and probe the speaker outputs and take a look and see what our DC offset is, because that speaker relay is not engaged. The protection circuit's doing its job because it thinks that there's something wrong and it doesn't want to damage your speakers. So we can't measure DC offset when a speaker relay is not engaged. So we got to find another way to measure the voltage that that protection circuit is seeing that's preventing the relay from engaging. The easiest way to measure the DC offset when you have an issue like this in a Marantz 2245 is at the protection assembly itself. And on a 2245, the easiest way is to put it on its side, take the bottom cover off, and you'll be able to get to the protection assembly easily, and you can measure from both the left and the right power amplifiers the DC offset. What I need to find out is this problem with the protection board itself, or is it one of the amplifier sections? So I'm going to measure from the right and the left channel the DC offset, and let's see what we've got. And I'm going to read the right channel. Let's see if I can do this without blowing the thing up even worse. It's about 20 millivolts. That's good. I mean, nothing wrong with that. That's not the reason why this thing why the speaker relay won't engage. So let's go to the other channel, which is the left channel. Well, there's your problem. I don't know if y'all can see that. That's not 36 millivolts. That's 36.4 volts. Will this blow up your speakers? Yes, it will. So there's the problem. So we can assume from this then, let me get the probe and my meter out of here for something bad happens. We can assume from that probably the protection board's good. Right? I mean, it could have a problem too after we fix whatever the other problem is. But the problem is with that left channel having 36.5 volts on it. So let's try to figure that out. So from the troubleshooting, we got a pretty good idea that it's not the protection circuit itself, because it was working. We saw 36 volts on the speaker relay, and it was certainly good that the protection circuit was working, or we would have had some melted speakers. With over 36 volts, it's got to be the left power amplifier's issue. So we're pretty sure that the right power amp assembly is fine because we saw a little over 20 millivolts of DC offset. When you narrow an issue down like this, now you can look inside your receiver and it doesn't seem so daunting. It doesn't seem so impossible to fix because you've narrowed down the issue and now you've got a shot at fixing it. Now, most of you don't have a Marantz 2245, and even if you do, you're probably not going to have the same problem this one does. As I indicated early in the video, this isn't about any one particular model. This is a video to help you fix your particular piece of equipment, no matter what the brand, no matter what the model. So before going back to the Marantz 2245 and showing you how I troubleshot this issue, I want to go through the service manual a little bit more, the schematic a little bit more, and the physical unit to show you how everything ties together. And remember, your unit will be very similar to what I'm going to show you. What I want to show you with this Marantz 2245 DC offset problem is how everything ties together. How the physical unit, where are those connectors? Where are those pins? Where are those designations on the schematic? Where are they in the service manual? How do I find them? And let me show you how you go about doing that, so that even though you're not going to be probably working on a 2245, you'll approach it the exact same way, no matter the make or model. As you guys following the video know, the 2245, we know it's got high DC offset. This is a section from the 2245 service manual that talks about the speaker protector relay circuit. And the speaker protector consists of, and it goes on here and talks about how the circuit's designed so no sound is heard. Okay, that's really, we know that, but it's not helping us. And then here, this circuit also protects the speaker systems against some troubles due to DC off balance between the speaker system terminals by instantly operating the relay and cut off the speaker systems from the circuit. The reason I mention this is, again, to get you to look at the service manual, because many times the service manual will help you, will direct you to where the issue is if you don't know where to start. It's not going to fix your problem, but it's going to get you somewhere. It's going to get you to a starting point. These images show you the component layout from the power amplifier assembly and also the protection circuit assembly. And you guessed it, it's in the service manual. The circuit descriptions, the component layouts, the schematic, they all help you repair your piece of vintage audio equipment. Did I mention that they're all in the service manual? We've eliminated almost the entire schematic. We know that the problem is right here. You may be asking yourself, well, how do you know the problem's there? You haven't even been near that P750 power amplifier assembly. All the measuring you were doing was on the protection circuit. So why am I so sure that the problem is actually on that P750? It's because all the illustrations tell me what is tied to what. And the reason I troubleshot this issue on the P800 protection circuit is I can get to it. The P750 power amplifier assembly is in a position you just cannot work on it while it's in the chassis. So I was able to troubleshoot the issue without removing anything. Not removing anything didn't last long, as you're going to see. But first let me go through how that P800 protection circuit is tied together with both the left and the right power amplifier assemblies. Here's the P750 amplifier assembly removed from the chassis sitting out on the test bench. In this image to the left is the P750 power amplifier, and to the right is the component location diagram from the service manual. And if you look over here on the P750, I'm just going to highlight these pins and go over here on the right of the diagram here and highlight the same pins. You can see the numbers correlate to each other. You got 761, 759, 760, etc. And you come down here and you got 761, 759, 760, etc. Now the pin we were looking at when we were looking at that P800 power protection circuit where we saw 36 volts is J757, this one right here. It's hidden a little bit by this black wire, but that is 757 over here on the P750. So the way it gets from J757 up to the power protection circuit is via wire. So it goes from J757, the right power amplifier assembly goes to J814. And the left power assembly goes from J757 to J813 on the power protection circuit. The power protection circuit that I was using to troubleshoot this issue is also the regulated power supply. We haven't even talked about the power supply because I haven't had a power supply problem. But just to make note of that, this P800 assembly has more than one job in this 2245. Just to note it because I've been talking about it so much, L801 on the P800 is the speaker relay. Alright, I'm going to get back to this 2245's DC offset issue and what I had to do to repair it. As you've seen so far, I haven't really had to do any disassembly. I had to take the top cover off and I had to take the bottom cover off, but that's been it. And that's the way you want to approach a repair. You don't want to start ripping the whole thing apart and then cause a problem that wasn't there to begin with. You do the minimal disassembly that you can. And I was able to troubleshoot this problem with a minimal chance of anything else being caused by me. But you still have to be careful, even if you only have meter probes in there, because you can short something out in an instant. So you have to be careful. It's probably more dangerous for the equipment than you, unless you're doing something incredibly stupid. So I've had to take a little bit more apart here now, other than the top cover and the bottom cover. I've got the left channel P750 power amplifier. I had to remove that from the chassis so I can work on it. There's just no way to work on it in the chassis. There's just no room. So I was working on on the P800, the protection assembly, and that was easy to get at, but now we know the problem's on this assembly, so there's just no other option other than to take it out of the chassis. And the first thing I'm going to do is look at that pin J757. That is a yellow wire over at the right side of the board, and I'm going to take a look at that. That's the lead that comes from the P800, the power protection circuit, the one that measured it initially. And I'm just going to make sure I've got 36 volts down there. Yep, so sure enough, I've got the 36 volts right on J757, and I thought I'd see that, but you always check it. Make sure. I can get to the component side of the board easily now, but I want to get to the artwork side also. So it's a pretty easy task to take the heat sink off. I'm going to pull the power transistors out. You just got to be careful of that bias transistor. It's held in with a screw, a couple small little wires, and you got that big heavy heat sink. So you got to remember to unscrew that, or if you've still got the heat sink attached to the board, it'll just break the wires right off. But I want to be able to get to both sides of the board easily, and it's much easier to deal with. I've got the heat sink off, got it in my hand here, so that's nice, right? I can take it out and I'll just take this right to the sink and clean it, get all that dirt out of it and everything. A lot of issues with all old stereo equipment, especially on these areas that do get warm, are solder joint issues. So I wanted to just eyeball it. I usually do anyway, but in this case, I'm definitely going to because we got a problem, and just see if I can see anything. Maybe some of these solder joints are cracking, and maybe it'll be that simple of a fix. So now with everything removed from this assembly, it's just so much easier to work on. I'll be able to flip it over if I want to, flip it back. So after doing this, I go to work on the problem, and guess what? The problem's gone. I don't have 36 volts on J757 any longer. I've got like 25 millivolts. Messing around with the board, taking off the heat sink, bending the board up and down. So I've got an intermittent issue with this board. What I started to do to try to make it come back, I just started tapping on it. It would come and go. 36 volts, 25 millivolts, 36 volts, 25 millivolts. Then I'd get it happy, then I'd get it unhappy. I took a look at the solder joints. They all looked fine. I looked at the artwork. It all looked fine. But some of this can be very minute. You can have a little crack in the solder somewhere. You'll never be able to see it. So what I did is I just hit the leads on the front half of the board, just kind of shotgunned. Went back to my tapping routine. It was solid as a rock. I could do whatever I wanted. I could move the board around in my hand. I could tap on it, whatever. It was fine. Now, I hate issues like this because you're not really sure. As I said, I don't know what fixed it, other than I think there was a bad solder joint somewhere. So you've seen how I approach a problem with a piece of vintage audio equipment, and I've tried to show you the best I can how I approach a problem. Now, let me tell you one part, for me, that's the hardest part. It's when you have troubleshot it down to one particular assembly, just like we did in the video. Now you've got to find that one component, or maybe several components, on that assembly that you troubleshot your problem down to. It's not as difficult as finding Bigfoot's vintage stereo system. But troubleshooting to a component level really takes some experience, and you'll gain that experience and you'll become better at it. For me, it just took some time. So I've gone through several different manufacturers and different models of equipment, along with what tools you need to repair vintage audio equipment. But one tool that I just mentioned that you must have too, if you really want to repair it, and that's a soldering iron. Now that you've got everything you need to diagnose a problem, now you've got to be able to repair it, and that requires some other tools. There's a few important ones, but probably the most important one is a good soldering iron. Once again, I'll say the same thing just like I did about the multimeter. You don't have to go out and spend hundreds on a soldering iron, but don't go to the flea market and buy one for $3. Get on Amazon, do a search, look at the reviews, and you can probably pick up a good soldering iron for $20, $30. That'll work fine if you don't want to spend a lot of money on it. And now that's for soldering, but how about unsoldering? And that's where it gets a little more complicated as far as I'm concerned to give you a recommendation, because as you guys know, I use that Hakko desoldering tool. I've got a couple of them actually. I got an older one and I've got a newer one, and I couldn't live without it. That's one of those tools I'm so glad I have. There there are some other options that you can use for desoldering. One is solder wick. Secondly, you can use a solder sucker. I don't think either one are really viable for working on vintage audio equipment unless you just have one or two components to mess with, because these would work better if everything was out on a table for you, was in a jig where you could get at it. You know, the problem is with either one, the solder wick, you've got to hold that solder wick onto the joint, onto the what you're unsoldering, and then with your other hand hold the soldering iron on there. And that's all fine and well if it's all in front of you. But as you guys have seen with this vintage audio equipment, this stuff is at all different kinds of angles, and you don't really have room to do that. And the solder sucker is the same issue. It would be fine for one component maybe. You'd figure out how to get it into some of these units to use it. But it really is not either one of those are not a viable option if you're going to really get serious in this hobby. Now I get it. Not everybody's got a ton of money, or even if you got the money, you don't want to spend a ton of money on equipment that you're not going to use very often. So if you do want to try to use solder wick, or you do want to use the vacuum pump system, there's a great video up here on YouTube that shows you how to use those and how to remove components using them. Now, you don't have to buy a Hakko desoldering tool. They're pretty expensive. They're around $300, give or take. There's some other ones. There's some off-brand ones that are cheaper. I've never tried them. If any of you guys have used any of these desoldering tools that are not as expensive as my Hakko, please put it down in the comments. And don't forget, you're going to need some solder. So now you feel you've learned how to repair vintage audio equipment. You've got all the tools you need. Now the age-old question is, while you are repairing your piece of equipment, do you restore it? Or do you decide to restore it even if you feel it's operating properly? More specifically, do you replace those old electrolytic capacitors? You guys that have followed my videos, you know what I do. I believe in doing that, but I also believe it's a decision made by the owner of that piece of equipment. And I'm not saying I'm right. I enjoy working on this equipment. I've got the parts, I've got the tools, and I enjoy doing it. So that helps me make my decisions a lot of times. It's not a big deal for me to get in there and change out those 50-year-old electrolytic capacitors that I think are ticking time bombs, because in my old age, I enjoy working on this stuff. You shouldn't attempt a restoration or a multiple component replacement without a desoldering tool of some sort. It is just a disaster waiting to happen if you get in there and you try to use the solder wick or the solder sucker or whatever. You need a good desoldering tool, or get somebody else to restore your piece of equipment. There are also transistors that are known troublemakers, as well as some diodes. So before you start a restoration, do some research on your particular brand and model. Almost everybody, unless you've got the rarest piece of equipment in the world, somebody's already done a restoration on that piece of equipment after all these years. Do some research so you know the known trouble spots in that particular piece of equipment, so you don't get all done with your restoration, you get it all back together, and you end up having to rip it back apart to fix something that you should have known before you started. And the question you got to ask yourself, should you start at all? Restoring a piece of vintage audio equipment is a pretty big job. Is it a job that many people could do? Yes. But it's not something you're going to get done in an hour or two, and you're going to run into problems. So you got to decide for yourself. We're all different. There's projects I can take on, I feel I can do. There's other ones I leave to professionals. And you guys, I'm sure, are the same way. I don't want to make it seem a restoration. Oh, don't try it. You know, you're going to get yourself into all kinds of trouble. But I don't want to also make it sound like, piece of cake. Open it up, you'll get it going in an hour or two, and you'll be able to enjoy it for the rest of your life. It's not that either. It's a pretty big project if you're going to restore a piece of equipment, and you just got to decide whether you're up to it or not. And if you are up to it, make sure you've got a good sturdy workbench. A lot of these big pieces of vintage equipment, you guys know, they're heavy. You don't want to put it on a folding table and have it collapse on you. And you want to be able to lay this out in a place where you don't have to pick it up every night, because it's going to take you a while to get this completed. In addition, do a component at a time. Don't take out 5 electrolytic capacitors and then try to figure out where they go back in. Unsolder one capacitor, remove it, note the polarity of it, install the new one, solder it in, and move to the next one at a time. Don't get a bunch of them out there and then try to figure out where they go. Also, with transistors, they have to be orientated correctly. When you're done with an assembly, if you can, sometimes you can't do this, but if you can, power the unit back up and just test it. Make sure you didn't make a mistake, because you're gonna make mistakes, and it's a heck of a lot better if you find mistakes before you get done with the project, and then something doesn't work, you don't know where to look for the issue. So as you work along, do your best to check your work as you're going. Been talking a lot about the receivers, the preamps, the power amps. But how about tape decks? And you know, tape decks, for me, they're tough. They're tougher than receivers, and they're tougher than amplifiers and preamplifiers, because you've got a whole nother side to them, and that's that mechanical side. Really, in a receiver, an amplifier, preamplifier, you've got a bunch of screws you got to get out of the way so you can get in there and work on them. And that's about the only thing mechanical you got in them. But tape decks, you're going to get into something mechanical as soon as you start messing with them. E-clips, C-clips, springs, little washers, some that are nylon, you can't even see them. So if you don't even know they're there, you can lose one. And in a tape deck, unlike a receiver case, you lose a washer from your case on your receiver and you put a screw back in without the washer. What's the big deal? Now, it would bother me personally, but a lot of people, it wouldn't bother them. Well, it's going to bother that tape deck, whether it's a cassette or an open reel deck or an L cassette deck, any kind of tape deck. It's going to bother it. You think, one little nylon washer, what can that do? A lot. So you've got a whole nother ball game involved with a tape deck. Add to that, to set up these analog tape decks, you really do need specialized equipment. You can get by with just changing the belts out, but you really don't know how it performs. But with saying that, I understand there's not technicians around like there used to be. A lot of you guys are on your own like I am. You just got to fix your own equipment. And is it worth going out getting specialized test tapes and test equipment just for your cassette deck or your open reel deck? Probably not. If I was in that position and I needed belts, I'd just get a belt kit and go for it. And if it sounded good, that's the way it would stay. Now, there is one option for testing tape decks, and it's a software solution, and it's called Nakamichi T100 Audio Analyzer. It runs on your computer. It costs you $25. If you're interested in checking it out, just Google it, and there's plenty of information about it. This will give you guys who would like to test your tape deck maybe a way to do it at a pretty reasonable cost. Most of the rubber belts in these 40-plus-year-old tape decks is shot. Some of them just disintegrate into nothing, just into like tar. Others are all stretched out. And to add to the problem, it's hard to find belts that will work in your tape deck, so that takes research in itself. Add to that the grease that is turned into glue in most of these tape decks. And you guys know, old grease, what's going to happen? It just hardens. And after 40, 50, 60 years, the majority of tape decks, you got to go in there, you got to clean them up, and then you've got to put in new grease. And if all this isn't bad enough, they still have the electrical problems that the other pieces of equipment have. They still have old electrolytic capacitors. They still have defective transistors. They still have all the problems the other equipment has. Tape decks can be really a pain in the arse. You can get the majority of the parts that you need to repair or restore vintage electronics at either Mauser.com or Digi-Key.com. Days are long gone where you can run down to Radio Shack and get a transistor or a couple capacitors. At least in my area, there's no electronic supply places, so it's one of those two. There's other places too. Most of the capacitors you'll be able to find no problem at all. Some of the filter capacitors may be tough because of sizes. That's another thing you've got to do. You've got to plan your restoration or your repair before you start it. With transistors, you'll probably need to use usually modern equivalents. And that's not a problem, but again, you're going to have to do a little bit of research to find out what modern equivalents you need. And if you're doing a project on a particular brand, a particular model, do a search on a build list. So let's say we were doing that Marantz 2245, doing a restoration on it. Google Marantz 2245 build list, because somebody's probably done it and somebody's probably listed the parts for you. We covered a lot of ground in this video, and I hope it helps you decide whether you want to restore your piece of equipment or repair your piece of equipment. And the goal was to really show you the best I could in a video what it takes to repair and restore a piece of vintage audio equipment. And hopefully it gives you a good idea. You can look in the mirror and you can say, I can do this. Or, I can't do this. I know this video was pretty long, and if you stuck all the way to the end, thank you. If you enjoyed this video, I'd appreciate a thumbs up down below. For you non-subscribers, I'd really appreciate a subscription. And for my present subscribers, as always, thank you so much. You all have a good day.